Well, welcome everybody. This is the November 18th, 2024 edition of Astro Cafe. Is there anybody new here tonight? I don't really see anybody. I'm not sure.
Chris, sitting beside me here, another Chris. He's never been to
Oh,
Enkin. You've been on Zoom, I think. Yeah.
And
oh,
Lena.
So
okay.
Zoom,
Would they like to introduce themselves?
yeah. Just here speaking to that microphone on the tube.
Yeah, just say a few words. Welcome,
Hi,
anyways.
I'm Lena. I moved down here from Colorado and I know there's a game thing and I'm interested in astronomy in this group.
So
And I'm a newbie.
we love newbies.
Awesome.
Excellent. There's lots of people. Have you joined the beginners group yet? If you haven't, please join.
You don't have it. I didn't know.
Yeah, there's a very good beginners group which David runs. And maybe you should give the spiel again, David.
Okay. So I don't know. We call it the beginner's SIG, but it's really a combo of people that are just starting and some more experienced people. So it's really, I would say it's kind of like a mini community, sub-community of cafe. We have a lot of fun. We have always have interesting questions to ask and to answer. I don't know if Lori has any more to add to that, or Margie. Oh, Lori says no.
And how do you join?
Well, you can just let me know. Send email to David at victoria.rasc.ca, and I'll make sure you get on the list. Great. Okay. So anybody else? If there isn't anybody else, we can talk about some other things here.
Well, Chris here.
Chris. Oh, okay.
Um, yeah, when you moved down here, about a year and a half ago down, we're living in Zug. Chris Purse and I met many years ago, in the Arctic, which is where I've been living up to now. Actually, I still have a place up there. So right now we're just shuttling back and forth.
Oh, so this is much warmer than you're used to.
Oh, yeah, it's water is a liquid, so
It's very cold for Victoria.
anyway, I've been doing it for quite some time, so.
So you must have some stories about viewing from up north then.
Yeah, or problems that I've never totally solved because of latitude.
Oh. Well, we always like to hear heroic stories anyways, so challenges or otherwise.
The challenges are mostly the northern lights that get in the way all the time. So.
Whoa.
Oh, we like the Northern Lights.
Okay.
Well, we see, and then the other thing is, of course, it doesn't get dark in the summer, right? So
Oh.
the viewing is quite limited in the north, actually.
For 4 weeks.
Yeah.
And then because of latitude, I think that our atmosphere column at the top of it, it's still getting hit by light, even if our days are very long.
Oh,
So it's you never get that.
It's a dork.
interesting.
Dorks.
But it's still good viewing.
Well, thank you, and welcome as well. Yeah, and I see a lot of familiar faces here tonight. That's great. So I unfortunately have to announce that Alistair Ling, who was going to speak tonight, he something came up for him, so he had to have a cancellation for that. So I'm sorry to hear that. Maybe we can rebook him at some point. And Randy, I think you're going to answer one of Margie's questions about Plaskett and his role in figuring out our place in the Milky Way. So I think that will be part of tonight's episode. And Wyman, I think you had a question about a publication that we've received, all should have received by now, the Observer's Handbook. So I'll be more than happy to. Oh, everybody, okay, all right. Okay, so yeah, so everybody's excited about the handbook. So we'll talk a little bit about that. In the past, we've actually gone through the handbook like a section at a time, but it's a good resource. And when we get to that section, we'll talk a little bit about it. There's a lot of people that heavily use the handbook here. I'm kind of in between, but it's got lots of good resources in it. And Lori, I think you were an author of one of the articles in the recent handbook as well.
Yeah,
Yep,
yeah.
she says. All right. Okay, so and Reg, I think I have you down here for something to do with some comet imagery.
That's it.
That's it. Okay. Okay. So that sounds really good. Does anybody else have anything for tonight other than what I've mentioned?
I want to
Hey,
know where Dave Kane
David?
is.
yeah, Dave is somewhere sunny. What's up
Yes,
with that?
I'm just watching the sunset in Maui
Oh,
here.
Oh, you're Maui.
So I've got one eye on you guys and one eye on the sunset. So
Oh, you
But where are you?
probably look at the sunset.
I recognize Haleakala behind you.
Oh, cool.
I
I
thought it
I
was a
knew
green
there-
screen, but the lighting was too good.
Yeah,
I knew something was up when you were in a t-shirt.
yeah. I
And
bet
I'm
you
bundled up here. Yeah.
I bet you it's super cold there, isn't it, Dave? It's terrible there.
Oh, it's terrible. Yeah. You think the Arctic's bad?
Oh, wow. All right. I have to
David,
ask you.
David?
Yes.
Yeah, Natasha here. I have a very short announcement. It can wait till the end about NASA's Night Sky Network and
All
a
right.
presentation that Kimberly's making tomorrow.
Okay.
I'll put it all in the chat.
Okay, I'll put it at the end here. And actually, while
Oh.
we were talking to Dave, I have a question for you, Dave. Will you be here to host the Astrophotosig at the end of the month?
I believe so.
You believe so? Okay. Okay. All right.
I'm in arrangements with Brock if I can.
Okay. So,
Dave?
yes, go ahead.
Can somebody talk about Marc Garneau's visit yesterday?
Oh, Wyman, hopefully. Yeah, I'll put that down here.
Oh, okay, great.
All right.
I just have a question, quick question. Lori, which article did you do? On which page? I can't find it.
I think it's around page 19 or something like that. It's the using the handbook for education, like for teachers and education. It's just 3 nice little pages that I do. So I think it's about page 16, 17, 18 or something like that.
It starts on 16, you're right.
Yeah.
Excellent. Okay. Without further ado, I think I'm going to hand the mic over to Randy. Please, let's answer Margie's question. Or should we ask Margie to pose the question first?
Sure. I am
Okay,
so
I'd
pleased that Margie's here. She was
Yes.
threatening not to come.
Yes, I was threatening not to come because I just came back from Mexico City from 9 days in Mexico City
Oh,
on an art tour. So that was wonderful. But in terms of Pacific time, I've been up since 3 a.m. So I don't remember exactly what the question was,
I'll
but
help you.
yeah, but yeah, when I was Googling a Plaskett, it mentioned, yeah, that's what it is. It mentioned about that. Yeah, there we go. There's my question. He and a colleague determined the size of the Milky Way galaxy and the sun located in it. Then when I Googled who determined the size of the Milky Way galaxy, of course, his name didn't come up, but Shapley and Hubble came up. So that was my question. What did Plaskett do?
Okay.
good question.
Excellent question, Margie. And I just love it. Every once in a while, Margie just sends a letter that QUE dot. And then there's something really interesting afterwards, but you never know what it's going to be because you have many interests. So this was one of those QUE emails. And so it reminded me of a very pleasurable time reading Dan Posey's thesis. So Dan, for people who don't know him, is our vice president. And he also is one of the people that helped our British Columbia election work so well. And he wrote back saying that this was his first weekend off in 3 months. So he's not here tonight, which is quite fine. But yes, so in 2016, he wrote his thesis, not just about the science of John Plaskett, but also of how the observatory was built into the fabric of Victoria. It's a great read. And then the other big resource, which I just picked up from Reg, because I never bought it, and I really have to buy it now, but it was brought out on the occasion of the 100th anniversary of first light of the big telescope here in Victoria, which for its first year was the largest operating telescope in the world, which is another thing you don't see in the Google. It's kind of hidden in there because there was a larger telescope at the time. The one here was 72 inches. The one in California was 100 inches, but theirs wasn't working. So there was a period that we had the largest operating telescope in the world. Anyway, I wrote that. And this is kind of the outline for the talk. So you don't have to read it yet because I will underline the parts that I'm going to go through. But this is basically, he gave me the outline for what I'm just going to say. So the first thing is that Shapley was indeed the first to arrive at a modern estimate of the Milky Way as a galaxy or as an island universe, is the word they had back then, and the position of the sun. He did this using variables in globulars and arrived at a figure of about 300,000 light years. And we often use parsecs, so just so you remember, it's about a 3-to-1 ratio. So 300 kilolight years is about 100 parsecs. 100,000 parsecs. Okay, so this is what Shapley did. He was a astronomer on Mount Wilson and Hubble's colleague. And he had the very clever idea of mapping not just where the globular clusters are, but also how far they are from the sun, from the Earth. And so in this diagram, we are here at the bullseye, okay? And the center of the galaxy, whoa, how do you know that? Well, it's where all the interesting stuff is. Notice how much people like to look at all the various interesting things towards Sagittarius. And it's got a high density of stars there. Anyway, as you point towards Sagittarius, look at that. That's where these globular clusters are pointing. They're not symmetrically around the Earth. Because there was a lot of talk then that it had been quite a while that at least the scientific community got to figuring out that the Earth wasn't the center of the whole universe. The Earth was rotating around the sun. But there still was this idea that the Earth was at the middle of this cloud of stars that we called the Milky Way because it looks milky. But what this map of globular clusters, these are little minor galaxies, little collections of, I think, hundreds of thousands of or millions of stars each, but they're very small and they're quite old and they are not symmetrically distributed. And then by measuring the distances, which was recently made possible, one way of doing it was by looking at variable stars, in this case, RR Lyrae variable stars, but also, and seeing how bright they were, but also by fitting the Hertzberg-Russell diagram, the color brightness diagram to the collection of stars, you could also get a bit of an estimate of how far things were away. He rather overestimated their distances. He did not take what's called extinction sufficiently into account. He didn't take the dust that makes stars look dimmer than they ought to. But he had this great diagram, and what's very important is when he puts a dot in the middle of it, it is right there. Okay, so he figured that we were 20,000 parsecs from the center of the galaxy. He published it, he gets priority. So the real answer, Margie, is because Shapley did it first. Okay, I mean, that's the fair answer. However, rather inaccurate and rather crude. So, and then this is a very important part that Dan Posey wanted to emphasize is that it really was Plaskett who put all the pieces together. And so it's kind of funny. I was watching this YouTube. This is an Astronomy 101 course. And here is a picture which is very, very similar to Plaskett's picture, which I had on the front cover of this presentation. But whose name is on it? Shapley. He didn't have anything that looked like this. He had what looked like that last diagram. Okay. So let's go to the next statement. Jan Oort, a Dutch astronomer, then conducted groundbreaking research in Leiden to demonstrate that the Milky Way rotates based on a thesis by Lindblad. This research adjusted Shapley's numbers and brought things more in line with our modern view of the galaxy. And so this is the paper in 1927. So the last was 1918, was Shapley. Here we are with Oort in 1927. And there are no images. The whole paper is made of equations, and it's not very easy to present here. But fortunately, in the biography of Plaskett, Randall Rosenfeld did these beautiful diagrams. And if you don't know about Randall Rosenfeld, you ought to. He is the, I don't know whether official or unofficial, but he is the historian of the Royal Astronomical Society of Canada and a charming fellow. When I went to Toronto just before the eclipse, he came in specially and showed me around the museum and helped me find books about the moon. And he's very proud of our legacy, the Royal Astronomical Society of Canada legacy. And it also turns out that he has a knack for taking complicated ideas, making beautiful diagrams that make sense of them. So here we are. Once you accept that the Earth...
Oh, Randy?
Yeah.
Randall calls himself, or he is called the archivist of the RASC.
Yeah. Very good.
That's his title.
Well, I was so pleased to meet him back in May. April? Okay, so here we go. Once you accept that the sun and the Earth are not at the center of the galaxy, but in fact are rotating around the center of the galaxy, then if you take a look at stars around you, the ones that are closer in are going to move faster, just like Mercury and Venus go around the sun faster than the Earth, and then Mars and Jupiter going around the sun go slower. So that's what this is supposed to show. So here we're looking at 9 stars in a circle around the sun. But you don't measure how fast stars are going. You measure how different their speed is, their velocity, so the vector, the their direction, how different their velocities are to the velocity of the sun. So in this case, the sun is moving. But if you are just stuck on the Earth looking at these stars, what you're going to see is that up and to the right, they're going to be approaching. You see? So if you subtract, oh dear, if you subtract the arrow here, you subtract the arrow of the sun, that's this arrow. Does everybody remember the vectors? You put one arrow tail at the head of the other arrow, and you get this little, that little resultant arrow. Sorry, my mouse is not being nice. But you see that you're approaching. The star on the top right is approaching the sun. The star in the bottom right is receding away. Bottom left, it's approaching. Bottom right is receding. That is very important. And this is the tool or the way of looking at the galaxy that Jan Oort had figured out. Problem was, he didn't have a lot of data. Meanwhile, John Plaskett, who was convalescing from being kicked off the ladder of the telescope by a 10,000 volt arc between an instrument and his head. Anyway, he fell off, broke his leg, and so he couldn't climb the ladders and do all the astronomy stuff. So he went to Europe and he visited Jan Oort, and he says, I could do this. I could do a really good job of this with our equipment. Anyway, let's jump ahead to 2022, 2023. I forget when the Gaia Data Release 3 came out, but this is a picture of 7 million determined velocities of stars around the Earth. Okay, so this is, I think Oort was talking about tens, Plaskett measured hundreds, but now we have millions of these measurements of how fast the stars are moving towards us or away from us. And I show this image now because it will make it much more concrete. But then just imagine if you just have a couple of points around on this sphere. So this is the whole sphere. And so imagine that we're in the middle of the wrapping of a globe. And as you point towards Sagittarius, you're pointing towards the center of the Milky Way, then these stars just to the left tend to be moving away from us, whereas the stars to the right are coming towards us. Then you go around to, looking 90 degrees away from the center of the center of the galaxy, and the stars are not approaching or receding us on average. But then we start pointing behind and to our right, they're moving away from us. Behind and to our left, they're coming towards us. And then let me just go back to the last picture. Do you see that that is exactly the same thing that Oort had predicted? And by actually doing the mathematics on that distribution, you can work out all sorts of things like how big the galaxy is, what its mass is, how long it takes for the sun to go around the center of the galaxy. You could do all that if you had this picture, but they didn't have this picture. This was just a weird, wild idea at the time. They did have the advantage that they could see other of these galaxies out there. That was interesting. You saw spirals or you saw some edge on and you said, maybe we're in something like those guys. Crazy idea until Hubble started measuring the distances to those galaxies. So that's why Mr. Hubble is the other person that you see in the Google response. Not that Hubble told us where we are in our galaxy, but he made it possible to see how big those galaxies were. Okay, let's go on. However, that's Oort, didn't have enough data to be strictly confident, and a secondary study was required for confirmation. Same thing as Eddington needing a secondary confirmation of light bending around the sun to prove general relativity. Now, what Dan is referring to here was Eddington in 1919, made observations proving that light bent around the sun during an eclipse following Einstein's general relativity. But then it was in 1922 that the great Canadian astronomer Cornelius Chant, was that his name? Who knows Chant's first name? Something beautiful like that. Anyway, University of Toronto professor, went to Australia, also measured the bending of light around the eclipsed sun and confirmed Eddington's measurement. And then just this year, Alan Goldman made a film about it, which showed up at the Friends of the DAO, and it's a great movie, and I hope everybody can see it. Anyway, that's what Dan was referring to. But let's go back to the letter. Plaskett connected with Oort there on a trip and began to conduct a similar study in Victoria. So in Dan's thesis, he said Plaskett quickly recognized that the DAO, the Dominion Astrophysical Observatory, could supply observational proof for their theories, traveled to Europe to meet Oort in 1927, agreeing that O and B stars. Okay, remember that looking at the spectra of stars, you can actually work out which are the hottest and brightest stars using the acronym Only Bad Astronomers Forget Generally Known Mnemonics. I want everybody here to remember that. Anyway, only bad stars are the brightest ones. And so there's the ones that are going to be furthest away. And so those are the best ones for looking and seeing whether they follow this pattern and doing the quantitative work to figure out where the Earth is. Plaskett and Pearce embarked on a systematic observation program of the O and B stars visible from northern latitudes that few observatories were capable of matching. After less than a year of studying 250 of these stars, Plaskett and Pearce produced a paper supporting the principle of galactic rotation. So it was still a new idea that provided insight not only into the nature of the Milky Way's rotation, but its overall structure. So let's look. So these are pictures that I took from the biography, Northern Light. So people who have been to the telescope on the hill here know that the light bounces off this huge mirror, and then way up, it bounces off a secondary mirror. The light then comes down through a hole in the big mirror and comes down to whatever instruments you like. And the main instrument that has been used here in Victoria was a spectrometer. So you put in either 1, 2, or 3 big glass prisms, triangles of glass, and depending on the sort of star, you choose which one is going to be the most effective. You put a camera there and you take pictures. Okay, another thing that you can see here is it says comparison arc. Now what that is as well as taking a picture of the spectrum of the star, you at the same time take a picture of the spectrum from some hot iron so that you know what the frequencies are. Okay, you don't just trust that the thing never bends. With temperature and all sorts of stuff, the position on the photographic plate could change. But by, at the same time, through the same equipment, photographing the star and something in the lab, you can then make comparisons, and then you can work out very accurately the wavelengths of the light coming from the star. And then if it's red shifted, it's moving away from you. If it's blue shifted, it's coming towards you. And then you can figure out, you can work out where we are in the galaxy. It's awesome. So here is actually the very first spectrogram that was produced here in Victoria. And you see the spectrum of iron above and below the light that came from the star, which is in the middle. And so you compare where these little white bands are to where the dark bands are here, and then you're able to work out the wavelengths of those lights, work out your speed. Here are their distribution of stars that they worked on. And so they're all over the place. And this is a really cool table. So in 1930, there were, what is that? 900 or so stars, O and B stars, had spectra that you could measure the speed with. But by far the plurality was done here at the Dominion Astrophysical Observatory, and also the quality of the measurements. So here they said that they could get them accurate to about 1.5 meters per second. And they're typically moving something like 200 meters per second. So, you know, we're talking about better than 1% uncertainty. But if you kilometers per second, yeah, fast. Compare that to the Lick, Yerkes, and Mount Wilson observatories, and this was the best place. And another thing that Dan was really keen that I understand is that the mount of our telescope was fantastic. And it was possible to set up the plate and move to the position and start taking the image, and what they would do maybe 5 or 10 minutes to get an image. And then it was only 3 minutes to go to the next star. So we might not have the number of clear nights that you have on Mount Wilson, but the efficiency and precision of the equipment that John Plaskett designed here was so awesome that it was by far the best instrument in the world to do this sort of study. Eddington remarked favorably on this as being the true confirmation of galactic rotation. So this gets back to Margie's question. Sure, Shapley, Hubble, Oort, they're all really important, but it was Plaskett that put everything together and was able to really say, this is the structure of the galaxy. I don't know why I put this quote in. Let's read it. Plaskett and Pearce were celebrated for their studies on galactic structure in their own time, but historians have tended to underestimate their achievements. Robert Smith, who I believe was actually Chris Gainor's thesis supervisor. Is that correct? Anyway, he's a historian in Calgary. Robert Smith describes Plaskett's work as an important secondary study that merely confirmed Lindblad's and Oort's findings. Yet during his Haley lecture to the Royal Society of London, Plaskett's contemporary Arthur Eddington, remember the guy who proved Einstein, credited the Canadian with conducting a remarkable investigation that provided the most convincing observational evidence on galactic rotation. So Dan finishes with all that lines up to what Plaskett and Purse actually did. They took all the disparate parts and then started mapping the movement of gas and dust as well as stars. They not only confirmed galactic rotation, the number of stars in the galaxy, the position of the sun, and the size of the galaxy, but they then created the first comprehensive model of this as a system rather than disparate parts. So I finish with Plaskett's beautiful image that he published in 1936, which was pretty well the picture of the Milky Way for decades and decades, and has only recently been surpassed. And with that, I end.
Great. Thank you very much.
Gary has a question.
Gary.
So Margie, did that answer your question?
It certainly did.
I guess it did, didn't it? Well done, Randy. Now, since we're on the topic of galaxies, all you galaxy guys and girls, one time at the Sierra Vista Astronomy Club, where we used to host dinner with our speaker, I weaseled myself into next to a galactic astronomer and peppered him with questions for hours, well, for about an hour. And he told me 3 very cool things, which I thought I'd share with you guys.
Great.
First of all, a galaxy can be considered to be a phonograph going at a certain speed. All the mass in the galaxy is considered to be a phonograph going at a certain speed. But the spiral arms aren't going at the same, the lit up spiral arms aren't going at the same speed. I think they're going slightly faster, and they're pressure waves going through the matter of the galaxy that generates star formation. Like, who knew this? You know, that's very, very cool.
Okay, can I just say something really important at this point?
Yep.
And this was mostly confirmed by radio telescopes, but also looking at other galaxies. But the further you go away from the center, you expect, if all the mass is at the center of the galaxy, for the speed to go down as one over the distance, and they don't.
Yeah, that was my next point, Randy.
Oh, I'll shut up now.
Anyhow, thank you, Randy, for that, which is pretty cool, which led to, of course, trying to figure out why that was happening and looking for dark matter. But an even cooler thing was, I said, I just don't get bars at the center of the galaxy. And he says, well, neither does anybody else, so you're in good company. But he said that, I said, do the stars actually stay within the bar or not? He said, no, they're buzzing around like little bees all over the galaxy, but for some reason there's this bar shape, or this long rectangle shape that stays in the center of some galaxies. Our galaxy had the bar in the middle. So I thought that was an amazing thing. The stars go zooming in and out of this bar, but the concentration looks like a big bar. There you go. Now
interesting.
You know. Yeah,
Dave, you have a comment? You have to unmute.
Sure, I've got a comment. Yeah, I've studied this quite a bit. To fluid dynamicist, it's kind of obvious what's going on.
Okay, Dave, you have only 2 minutes to respond.
Okay, go to your sink, fill your kitchen sink with water, and swirl it with your hand and undo the plug.
Yeah, it's a vortex.
And that's a vortex. That's exactly what the galaxy is. So there's 2 kinds of rotation. So on the outer part, the stars are basically where the gas creating them is. And the gas is in a disk that's rotating around the center. The center of the galaxy is only 0.1% of the whole galaxy. So it's not like this giant mass at the center of the galaxy. Most of the mass is in actually the gas and some in the stars. So you can see that if you're in the middle of the galaxy, you've got mass that's further out, that's pulling you out, and mass that's towards the center of the galaxy that's pulling you in. So it's not like it's a ball spinning around the center. You've got mass all around. It's pulling you in different directions. So there's two kinds of spin. There's the spin like a phonograph that you said, and that's a solid sort of spin. And when you get to the bar at the center, the individual stars are spinning, and it spins like a phonograph. But as you get further out, it's spinning at a different speed. So the angular momentum increases as you get towards the center. So that sort of explains the bar at the center versus the spiral that's further out. It's kind of like the eye of a hurricane. If you, the center.
It has sharp edges, though, Dave. It has sharp edges, has corners. If you look at some of the bars. Anyhow, we shouldn't bore everybody else with this stuff.
Anyways,
it was fun to talk about.
It was curious that the original study looked at globular clusters, because they're the only stars that we know didn't come from the Milky Way. They actually came from elsewhere and got hold of our gravities. And it was interesting because they're spherically distributed. And that's kind of why he could use the globular clusters in a spherical distribution about the center of the galaxy, particularly at the size of the galaxy. If you pick other stars or other clusters or something like that, well, they're in the disk because that's where they were created. And so it wouldn't have worked out so well. So you have to go to a more sophisticated way, like you described. So it's really interesting about history.
That's cool.
Very cool.
I saw Susan had a question.
Yeah, that's right. Susan, do you still have a question? Okay. We can always come back to that. Yeah, I did notice that Susan had her hand up. Yeah. Yeah, thanks, Randy. That was really good.
I have a question, but it's not related to my original question. Randy, are you able to go back to that photograph you had of the Plaskett telescope and the spectrometer on the bottom of it?
Yep.
Is that the same one that has the clocks in the background?
Oh, might be.
Yeah, there's two clocks in the back.
Come on. Let's try that again.
There it is.
There it is. Yeah. Yeah, nice. I noticed some labels on the telescope. So I noticed it says guiding eyepiece. What I have wondered for a little while now is where would originally the telescope had an eyepiece, correct?
It had two. You could look down through the Cassegrain position, which is through the hole, and it had a Newtonian position. So you could put in a diagonal instead of a horizontal mirror up at the middle and look out the side. When it was public viewing, does anybody know where the eyepiece was for public viewing? Was it down in the bottom?
It was at the bottom because I was there.
I used to climb up the ladder 20 years ago.
Yeah, you had to climb up a big ladder.
Yeah, look at those magnificent wheels with knobs on the handles and stuff. Like that's real astronomy. That is, boy. None of this.
Oh yeah, look at that.
Yeah. And my other question is where would the photographic plates originally have been placed in order to take photos?
So if you're taking a picture of part of the sky, you would probably you'd be way up at the top of the cage in what's called prime focus. You'd probably put the camera right there up in the middle of what's called the spider. because you want to have as little glass between you and the image. So I imagine that the first photographs were done by somebody climbing up there into the cage and setting up the camera up there. Otherwise, they would do it in the Newtonian focus or down in the Cassegrain focus, which is down here. So you would put the camera here. In this case, that is the camera for going through one prism. So the light would come down and then bend a bit, and that was where you would do the photography.
Randy, I can confirm what you just said. I go walking every week with Dr. David Crampton, who retired from DAO a little while ago. And he was telling me the other day of the plates being way up high at the prime focus and having to go up there to guide the scope. So the astronomer himself would be sitting in a little cage, all cramped up, cold as can be, miserable, guiding the scope with the plate next to him. So it was quite a robust profession. Because
so Gary, that would have been in the Newtonian mode, right?
No.
No.
Dave Crampton, when he started at the Canada, France, Hawaii telescope, would be in the middle of the telescope.
Yeah.
And the quality of an astronomer, he said, was how long they could stay up there without having to go to the washroom.
Great.
Do you have to put that on your resume?
He said he was very good at that.
Okay.
There you go.
Women would be better.
Great. Well, thank you. Any more questions for Randy?
Could I have a comment? That guiding eyepiece, that was usually used for the spectrograph, and they would have a starlight go down there and they'd have a prism and make it into a slit. And the observer's job was to keep the star right in the center of the slit. And years ago, when I was a child, I did that job as a summer student at the observatory with that telescope.
Wow.
Wow.
On the Plaskett.
Yes.
Cool.
So, Reg, we have you to thank for Sharp Stars?
Absolutely.
In the 1930s. And that was the pre-script of modern video games.
But you have to give us a talk about working up there.
Yeah, for sure.
Okay, we've got a few other topics here. Now, since you were talking, I wonder if we can jump to you for whatever Comet stuff you have.
Okay, before I get any further, the talk was on Plaskett and Joseph Purse. Last spring, Dennis Crabtree brought to the UVic talk, and David, you recorded it, a great talk on his historical aspects of setting up the telescope, but he brought along Richard Pierce. Richard Pierce, Joseph Pierce's son, and Richard Pierce grew up on the hill, and he had plenty of wonderful stories to tell, and he was a delightful man. It was a great honor to meet him because I knew of the terrific work that Joseph Pierce and Plaskett had done. So this was a great topic for me that I really enjoyed it.
Great.
So could I please share the screen?
Yeah, please.
Okay.
Lori has her hand.
Lori has talking loud enough for the people out there?
I can hear him. You could speak a little bit louder. Now, Lori, did you have a question before Reg starts?
Yes, I just wanted to, just one little story that Richard told us one time was, I mean, he was only like 8 and 9 and 10 years old when he lived in the White House, which is the house beside the observatory that now is offices and things, and they used to live in there. And he remembers having astronomers come that would be invited to come to the observatory to work, and they stayed at the White House in a couple of the extra rooms, I guess. And in the morning, he said in the morning he remembers having breakfast in the morning with these famous astronomers who he didn't really know. I mean, as a 9 and 10-year-old, he didn't really know this very much at all, but he remembers vividly his dad and some of these astronomers using things like the salt and pepper shakers and things like that on the table to say, well, this is where this is, and then this was where this is, and then this goes around like this. And he says he remembers vividly having these different things, the condiments on the table being being what they used in order to talk about what happened. It was just one little thing that he said one time, which I really loved. I thought that was really a great story. So there's lots of them. Yeah.
Lori, did he ever mention what as you're walking to the VCO from the parking lot, you go by this little barracks, it looks like, on the right at the bottom of the hill? That was the dormitory where the astronomers would sleep during the day. Is that true?
Yes, I slept there.
Oh, you did? Oh.
Yeah.
Isn't that still in use on occasion?
Yeah.
Yes, yeah, it still is. Yeah, they
yeah.
still use that too. Yeah.
Because I recall somebody showed up at the VCO one night years ago to see what we were doing, and I think they were staying in there.
Oh.
Yeah.
Lori, could you lower your hand? Thank you.
I can't seem to be able to. Can anybody see? Oh, you can see it.
Oh, yeah.
You just need the slideshow mode or whatever.
Yeah, you have to get your controls out of the way. Yeah, that's perfect.
Zoom has just done some horrible stuff. So I'm just going to
And if you
say,
kick that into slideshow, that should work.
So, all right. So it's kind of appropriate
there you go.
that we talked about Jan Oort, because in 1927, he published the equations of motion for the galaxy. And here the Oort clouds comes up here. So the comet, whatever you call it, I call it comet begins its long journey back to the Oort cloud. So this is a talk basically about our adventures. So first, some background on the comet itself. It was really discovered on January 9th, 2023 by the Purple Mountain Observatory in the center of China. And that observatory used to be really quite prominent, but pollution, light pollution, and that has been a bit of a problem. And it's now mainly focused on looking at near Earth objects, stuff like that. They saw it on January 9th. Nobody else followed up. So at the end of January, they said, well, this must be an error. And then on February 22nd, 2023, an ATLAS group, another near object observatory mission in South Africa, found it. And so both names are on the thing. But the such and such team are the ones who really discovered it. So its perihelion, the closest point to the comet came to the sun, occurred on September 27th, 2024. And its closest approach came to the Earth on October 12th. And it was 0.47 astronomical units away. And David Lee rallied the troops, and we had a great crowd up at the observatory that night, because we didn't know if the comet was going to survive its way around the back of the sun. And we saw first light there, and it was kind of neat. All of the, it was a forest of tripods out there. And there's a bunch of them, and they're all lined up against the railing looking to the west. And it must be what it's like on a cruise ship during the night. Lined up there. And it was a great atmosphere, but there was a lot of cloud around and stuff like that. And finally, David found the comet. It was his Telebo Pronto, and there was great excitement. And then everybody started seeing it. And it was a really exciting thing, because we never knew what was going to happen. Quite often, these things are kind of canned, and we expect it to happen. But this was a true adventure. It was one of the highlights of the year up there. Now, the there's some statistics on here. When the aphelion, the farthest away that the comet is 270,000 times the distance from the sun to the Earth, which is staggering. That was when it was where it came from in the Oort cloud, and on the outbound, because it's perturbed its orbit, it'll probably only go out 3,800 times the diameter.
Only.
The distance between the Earth and the sun, which is still fairly healthy. But the thing is that there's a thing called the eccentricity. Now, all of these orbits are elliptical, and a circle has got an eccentricity of 0. A straight line has an eccentricity of 1. The eccentricity of 0.9999985.
Wow.
So they figure it's going to be down to 0.9998981 for the next thing.
So wait a second. What makes it change?
Pardon me?
What makes it change?
The interaction with all the planets, Jupiter.
The sun too, I would say, right?
Yeah.
Oh, right.
So the orbital period was 110 million years, but it's going to come back, and now they estimate 235,000 years.
That makes it better.
Basically, for us, it's on its farewell tour. So we should try and see it again if we can, and hopefully the weather will break and that happens. Now, its orbital speed when it came to around perihelion was 67 kilometers per second, but relative to the Earth, it is 80.5 kilometers per second, because it's coming in the wrong way. It's coming in. We're all going around the planet in as one direction. It's coming in the opposite direction.
Oh.
So the speeds are adding. So it's called a retrograde orbit. So at any rate, up there, I did not have very good gear. And this is an example of you can have a lot of fun with not very much. So what I've got is this a little refractor. It's a 61 millimeter, but a telephoto lens could do the same thing. And it's hooked up to my Canon Rebel. It's called a T3i. It's an old Canon. And it had a focal length of 360 millimeters at f5.9. The Canon wasn't a big one. It's crop sensor, so it wasn't as big a chip as some of the more expensive ones. And the important thing here is that I have this wire connected to it. It's for a remote shutter release, so I'm not pushing the camera down. Now, I had it on a flimsy tripod. There was no tracking, and because there is no tracking, and with this focal length, I couldn't take an exposure more than a second. So I took a series of second exposures. And the most important thing, first of all, is to focus the scope on a star. When Arcturus was right there. It was a beautiful evening. We had Arcturus in one area, and we had Venus down here in the other area, and the comet was about mid-between, on the line between the two. So you focus on Arcturus, and this is one of the advantages of a telescope, is you have better focus than the helical adjustment with a telephoto lens, but I digress. So at any rate, this is the first image, and this is 12 1/4 second exposures that I stacked in PixInsight, and I used a special thing called comet alignment. I am in no way proud of this picture. I've never been able to take pretty pictures. I'll leave that to others, but you can see there is bands of cloud. These are kind of smudgy because the focus when they stack is on the nucleus of the comet. And if you look there, the comet's it's got a little bit of a spike there. We'll go into that later. And then that was at 7:25. A little bit later, it got darker. So I took 18 exposures at half second, and it was crisper. And you can see a little fleck on the nucleus at this time. So the darker skies improved the signal to noise ratio. And I used, actually I used 15 images that I stacked. I guess some were rejected. So that was again on October 12th. And then on October 22nd, we went back up there. At this time, 10 days later, the comet was much higher in the sky. It was later, stars were much darker. And I began this exposure at 8:23 p.m. The reason that I started it so late is that we were trying to get the VCO Takahashi refractor ready to point to the nucleus of the comet. And I was giddy with excitement that we were going to showcase the beautiful Takahashi refractor on this, but the computer died. So I wept. But then I madly went out there and I put my equipment together again and I took this picture. And then this is the path of the comet, and it's hard to see here, but we on the 12th we were actually in the comet was in Virgo, and by the 22nd it really moved along, and then it started to slow down, and it was in Ophiuchus. You spell it Ophiuchus?
Ophiuchus.
Ophiuchus.
Ophiuchus. Yep.
Anyway, I tell you, it's worse than such a. At any rate, it traveled quite a long ways. And I noticed that the comet appeared much smaller on October 22nd than on October 12th. And I said, aha, this is an opportunity. The light went on. Said the optics are identical. So I've got these two pictures. If we compared the images, everything geometrically should be the same. We might be able to estimate the distance of the comet on October 22nd and the average speed relative to the Earth. So that was my naive suggestion. But when you're comparing comets in size, it's a challenge. Well, the comets aren't distinct. They're not like 2x4s or something with a crisp edge. They are clouds. So they're not a solid body, and the edges of tails are diffuse. And the cloud is reflecting sunlight. The denser, brighter, the denser the concentration of particles and dust is, the brighter the reflection. And the comet will become dimmer as it recedes from both the Earth and the Sun. The nucleus of this comet is estimated to be about 3 kilometers and is more like a sprinkler head pointing towards the Sun. This little tiny sprinkler head is spewing out particles of dust and gas, and the flow of the dust and gas particles emitted by the sprinkler head will decrease as the comet retreats from the Sun because the temperatures will drop and the outgassing will drop as well. So in this exercise, we assume the flow remains unchanged in a 10-day interval between the photos, and therefore the size of the comet will remain unchanged. This might be a pretty rickety assumption. And the other thing is that when these particles are emitted from the comet, there's all sorts of forces acting on them. There's the gravity, there's the radiational pressure of the sunlight, and then there's solar wind particles, some of them charged particles spewing outwards. Now, there's an interesting thing. There's a critical diameter when the radiation pressure is in balance with the gravity. And stars with a larger gravity, a larger diameter than about 200 nanometers, gravity wins and they'll slowly spiral towards the Earth. If they're smaller than that, the dust particles will be pushed by the radiation and move outwards. Now, there's a tool in PixInsight, our wonderful but hideously complicated program that processes our satellite imagery and stacks, our astrophotography imagery and stacks it up. And people like Dave Payne and others are absolute wizards at making this thing sing. I have a heck of a time with it myself. But at any rate, there's a tool there that I stumbled across that might be useful. And it's a script that if you went down here, like there's literally hundreds of different programs and processes, including one that Dave Payne developed and is used all around the world. These things will, if you go down to render and click on to 3D plot, it will come up and it will say you can set an azimuth and an elevation and push a button and it will fill up your disk drive. Some of these files I had were up to 1.3 gigabytes in size. So they're big files. At any rate, this is one that shows the October 12th with an azimuth of 30 degrees and an elevation of 20 degrees. I want you to look, this is the tail, but right near the nucleus, you can see something that has kind of a Mount Baker type quality to it. And it's a beautiful thing. So if I change the elevation to 90 degrees, we're looking right down on top of it. And the nucleus is here and the tail extends out this way. That's the October 12th one. And if you look at 0 degrees, you're looking right towards the comet head on. And
in a grassy field.
Yeah. So it looks, this is really eye candy, and I got a lot of fun messing around with this program. And you can apply this to galaxies and everything, but that's what I used here. So that was the October 12th. And then I swung it around. I went to an azimuth of 90 degrees. And you can see that the tail here and the nucleus is up here. And if you blow it up, you can see the interesting shape that this has, where the solar wind and everything is hitting the comet here and is building kind of a shock wave up here. And then it gradually tapers off and dissipates and diffuses as the particles go off into the tail. I'm surprised for what a rudimentary photograph that I took on a rickety type tripod. I could have stuff like this coming out, so it was kind of neat. At any rate, going on to the October 22nd one, where we had 115 1-second exposures, it's a lot crisper, but it doesn't look, it's a lot smaller. And I used the same thing with a comet alignment. What you do is you don't align on the stars, you align on the comet head. And you start at the first picture you take of the comet head and click on the last picture and it lines them all up and it stacks all the pictures. So all of this other stuff here, these unpleasant things here are star trails. And that they're considered bad form by astrophotographers. And some people would get rid of them, but I didn't do that. At any rate, so what we'll do is we'll go here, and this is at a certain azimuth of 50 degrees. And you can see the stars even stack up and they have a little intensity profile as well. But this is the nucleus of the comet. And here's at 70 degrees and at 90 degrees. We couldn't get it to go exactly horizontal or parallel to the view. But if you look at it from a top view point of view, the summit or the nucleus is right here, and you can see really quite a good contouring program to identify and locate the center of this nucleus. And if we go here on the side view, these are the stars, but this is the nucleus of the comet. You can see that steep slope is still there on the 22nd on the front, and this gorgeous little curve coming down the back. And there might be information in the shape of that curve that would describe what the diffusion process is for the dust of the comet, but that's not for me to decide. At any rate, on the 22nd, at looking down from the north, you can see the center of the nucleus here. And a front-on point of view, you have this thing here, and it looks quite beautiful. And so what I did was that initially what I did was try to measure the width of the comet as it intersected through the nucleus. So it was 780 pixels here and 425 pixels there. Pretty rudimentary here. But the estimated distance of the comet, all you do is divide 780 by 425. And on October 12th, it was 0.747 astronomical units. So on October 22nd, it would be 0.86 astronomical units. Now, unfortunately, Sky Safari tells me that on October 22nd, it was actually 0.06789 astronomical units. So way back when, I said that we assumed that there was no change taking place, but perhaps the comet cooled down during the 10 days, and it might have actually shrunk the size of the nucleus in that area a bit, and a smaller nucleus would increase the distance estimate. So I was going to take it further, but I thought I'd quit while I'm ahead. But I just want to say, beware of eye candy. This picture, these two pictures here, this is from the 12th, and this is from the 22nd. These are kind of probability type distributions, and I was going to use a device called full width half maximum measurements to take this when I realized that that really is not what was going on. But I'd leave it there, and I had a lot of fun doing this, but the use it was not very much, but that's what it's all about.
That's great, Reg. You know,
Wow.
I was looking at the contour analysis that you've done. It's kind of interesting. The latter image just makes the nucleus look more pinpoint, right? And you can kind of tell that from the contour. There's that rapid peak rather than the gradual peak that's on the 12th.
Yeah, well, there's two reasons. That the 12th was much closer, and two, I had really only about 15 images compared to a lot of 190 on the other one, and there was quite a bit longer. The exposure, better signal to noise ratio, and it really makes it a bit crisper and gets rid of all of the side splatter that shows up on these comet tails.
I just want to say it's amazing what you can do with short exposures. I know we always go for long exposures, but when you can't, you can still do it.
It was a happy accident. It wasn't planned.
There you go. Lori. Oh, way to go, Reg.
Yeah.
It's very interesting to see how much our solar system had the effect of it on its orbit. Like, boy, it really made a change to, the period and all that kind of good stuff. Is that predictable, or is it almost impossible to predict because all the planets are in different positions, and it'd be a bit of a nightmare? Any idea on that one?
Yeah, well, first of all, I got that information from Wikipedia, and in front of it, they had wavy equal signs, which means
approximately.
But it's very difficult because as it's shooting around, it's interacting with all of the planets, and they could perturb it, and then God knows what else is out there that it's finding on its way back to the Oort cloud.
Lori, your hand is up.
Yes, I wanted to ask for those of you who'd seen some of the other pictures, the images that were coming from the comet, there seemed to be something coming out the front of it. And I didn't know, I think it was Deborah Saravallo had some like that, and I didn't have any idea what that was.
I've forgotten the name of it. There's a name for it.
An antitail?
Antitail. That's what it is.
So where does that come from, Reg?
Well, I'm not an expert on that, but I think that when that picture was taken right when the comet was in the orbital plane of the Earth, and actually we could see possibly some of the tail from its previous trajectory as it came into orbit. I think that's why it'd be what you're seeing there. But
okay. Yeah. Okay. I was trying to figure out what that was at all. Okay. Thank you. Yeah.
Right. Shanae? You had your hand up as well? You need to unmute yourself.
Sorry. Yeah, so I'm probably, well behind everyone here in understanding these things. So I just had a basic question. So if a comet, like a comet is gas and dust, you described it as, and I checked and it's described as ice, isn't it?
Yeah, they often call it a dirty snowball. That's a common terminology for it.
So and what, when it's solid, it's an asteroid, right? So what is actually, when things penetrate the Earth's atmosphere, is it really an asteroid or can a comet? When they talk about those indentations, like
Yeah, I don't think this is of the nature of a asteroid. This is a more of an orbiting object that goes around the sun, but it's mostly ice and dirt, right?
yeah. So
An asteroid is rocky.
yeah, my question is, can a comet penetrate the atmosphere given its composition?
If it lined up, it could. But basically, Fred Whipple called these things dirty snowballs, and that model was recently refined to an icy dirt ball. There's a whole pile of particles in there as well as the ice. And many of the asteroids that we have, they think is that they've made many trips around the sun. And each trip, they exhaust some of the moisture there. So you only end up with a rock in the end. And one of the asteroids associated with the big meteor shower in December is actually not a comet. It's called a rock comet, and it probably was a situation where it exhausted all of the moisture some time ago. But there is a really great comet, usually around the what do we call it?
A meteor shower?
A meteor shower on the 12th of December. And many years ago, John McDonald got a great picture of this comet, shooting star. And he took pictures afterwards, and it left a trail that lasted for many minutes. And that ruined my Christmas. And anyway, trying to figure out that thing. That was in 2015. So you have to worry. You have to. A lot of great things are involving comets or asteroids.
Yeah, I think Bill just left Sky and Tell article about comets. If you want to learn more about them.
Is it not speculated that the Tagaski meteorite was actually a comet, and that's why there were no significant meteorites found at the impact site?
Yep.
In 1908.
Oh, that one in Russia.
Yes.
Siberia.
Interesting.
I think
I'll have to look that one up again.
The impact might vaporize a lot of the rock. And they scattered over a huge area, any sizable chunks. A lot of it's probably get vaporized when it hits.
Great. Any more questions for Reg? Okay. So you probably noticed that Reg was sort of bemoaning the death of our PC at the VCO, but we have good news. We have ordered a new computer. So I think the pieces are going to be coming soon. I've ordered a few pieces and some licensing, so hopefully we'll be up and running again. Great, thanks, Reg. So Wyman, you went to a book signing recently. Can you tell us about that?
Yeah, so yesterday there was a book signing at Bolen Books, and the guest speaker was Bob McDonald and Marc Garneau. And I think I saw Chris Gainor and his wife, and Chris Purse and his wife were in attendance also. Just about 145 people, stacked up and listening. It was a very good crowd. It was quite interesting talk. Marc Garneau is speaking about his journey of applying to be an astronaut. I guess he was up there 3 times doing the space station stuff. He's getting a good brief history, and then he became the president of the Canadian Space Agency, right? So it was very good of him to describe Canada's journey into space. I guess we were the 3rd country in the world to have a satellite in space, and I think our first satellite was Alouette, was it? I think.
Yeah, Chris probably can confirm that, but I think it is.
Yeah, one was that. And so it was the Russian was Sputnik, and then the Americans, the Explorer, and then we had our communication satellite, the 3rd one. And the funny thing is, our satellite is still up there, whereas the other 2, they're down, right? So it was
Telesat.
Yeah, it was one of those communication ones. So we were the first country in the world to have communication satellite for our vast country. It was kind of nice to hear. See what else was there. It was just a really fascinating experience of the wonder of seeing space from up there in space. It takes about 20 minutes for the station to go across Canada, so it had a good 20-minute view of the country. Stuff he noticed a lot is climate change, the impact on the world and that stuff. What else he said? Oh, he gave out a budget figure, like how much you think we pay to support our space agency, all the stuff we contribute to space exploration. Our budget, every man, woman, child, we pay $10 a year.
Wow.
And Bob McDonald said we spend more of that on Halloween than on space agency, which was kind of rams at home. Yeah, it was quite enjoyable. It was very good. Maybe Chris can talk more about it. I was just very impressed. It was really proud to be a Canadian to hear what Canada contribute to the space technology. Yeah, it was really good.
Yeah, Canadians forever understated.
Really understated. We don't say much, right? Yeah. Yeah, it was really good.
Any comments, Chris?
Let's see. Here's a picture I took there.
Yeah.
And or actually Audrey took it. I didn't realize. I don't know why I'm getting echo here.
Yeah, there's a okay. Let me.
Anyway.
No, that's not
I
it.
think it's Wyman.
Now try it.
Hello. Okay.
It was Wyman.
Yeah.
David, we muted you, by the way, so you want to unmute yourself? David Lee?
Yep. Okay. Yeah. Thank you.
So, yeah, I didn't realize that Chris Purse was there, but anyway, there was a good crowd on hand, and I just started to read the book this evening, and it's certainly quite interesting. He talks about the 3 careers he had. The first one being in the Royal Canadian Navy, and he was a electronic warfare specialist, I think, in the Navy, and actually had no idea about going into space. But then one day, the Canadian government accepted an invitation from the Americans to join, to send up some astronauts. So in 1983, he replied to an advertisement in the paper. I also clipped out that advertisement, but I never replied to it because I I don't apply for things I don't think I have a shot at. So I know some people did just so that they have the rejection letter. But anyway, there were 6 people who were chosen to be astronauts, and at first there were only 2 slots, and they were supposed to fly a couple of years after that in 1985. But what happened is that things were changing quite quickly, and a spot opened up in a flight in 1984, and Mark was chosen for that. So on October 5th, 1984, he was on the 13th shuttle mission, which flew on Challenger. And Challenger flew, I think, 10 times or something. And the last time, of course, is the one we all remember. But I think he was on the 6th Challenger mission or something like that. And so he had a modest set of Canadian experiments. But later on, he when the Canadian space program became more involved with the shuttle and there were more slots, he flew 2 more flights for a total of 3. And on the last 2, he got to operate the Canadarm on one flight to move a satellite around, and then on his final flight, he was helping to assemble the International Space Station, moving a module out of the shuttle onto the station. So yes, he talked about that. But after his 3 flights, he was president of the Canadian Space Agency for a few years. And then he was invited to get involved in politics. So he ran for the Liberal Party in basically his hometown of Montreal. I think the first time he lost, and then he did win, and was in opposition for 7 years, and was in government for 7 years as Minister of Transport, and then Minister of Foreign Affairs. And he retired 3 or 4 years ago and wrote this book. And somebody said, "Well, what are you working on now?" And he says, I'm learning to cook." So anyway, so he did get some questions about his political career, and of course, he did observe that it was a transition, from being a very, very popular and universally popular person to somebody who is not always so popular when he got into politics. Anyway, it was an interesting thing. He's doing a tour across the country now with his book, and I think I showed that slide a little earlier of his book, and so it's available from Bolen's or other stores in town, and I would recommend it. He was asked about the space program. I'll just say something. Explorer 1 and Sputnik didn't, Explorer 1 stayed in space for about a decade, and Sputnik just a couple of months. But actually, the oldest satellite that's still up there is Vanguard, which is an American satellite that was launched shortly after Explorer 1. Actually, Vanguard was famous because Vanguard was supposed to be the first American satellite, and it failed spectacularly. It blew up on the pad, and everybody was watching it. But yes, Alouette was launched on an American rocket. We still don't have a Canadian rocket capable of sending up satellites, although people are working on that now. And it was very successful. It operated for 10 years, and as Mark said, it's still up there. And Mark's presentation, by the way, was with Bob McDonald, who we all know. And they had a very good conversation because, of course, both of them are knowledgeable in that topic. So I think I will leave it that there unless somebody has some questions.
Well, thanks, Chris. I noticed that there's actually a lot of astronomy-based books out right now, and to put a plug in for Bob's book, Bob's got a book out right now as well, right, Chris?
Yeah.
Yeah.
So Bob, he just very his current book, I think, is called "Just Say Yes," which is his own memoir of his life. He's quite an interesting character. He I don't think he ever got through university, but he's just an excellent communicator, as we all know, and was interested in science. And actually, when I got home last night after this event, they had an interview with him about that book on the National. So if you want to pull it up on Gem, it's near the end of the show, but it's quite interesting. And there's some shots of Bob McDonald from the 80s, when he had the, mullet and all this. But yes, he's also, before his book, just before that was about climate change, but not the usual thing about wringing one's hands, but possible technical solutions to some of the issues around climate change, and that's just come out in paperback now, so it's priced a little lower. One book of his that I like, he did I don't know, about 5 or 6 years ago, maybe a little longer, about I think it's called Canadian Spacewalkers. And almost nobody has written a book about walking in space. And I thought he did an excellent job on that. So if you're interested in that topic, you should look for that book. And the production on that book is really excellent. So
yeah, one of the walkers was not Marc Garneau, but he did, of course, train to go out in case he was needed to, because he was a backup on at least one of those missions to go out into space, but he didn't actually have that experience. The other thing I thought was interesting, if I can just mention too, was that he wasn't a pilot. A lot of astronauts have started off life as Air Force pilots, but in fact he wasn't, and that's quite interesting, because when you look at the background of many, that seems to be where they start.
Mm-hmm. Yeah, like Chris Hadfield, for example, or
and many in the U.S. and it shows us
right.
U.S. astronauts, they've been Air Force pilots previously.
But I will say one thing about that is that most or the Canadian astronauts, the first group anyway, the first half dozen, weren't pilots. I think maybe one or two of them were. One of them who was Bjarne Tryggvason, and that was just something he did as a hobby. But he knew how to fly, and he actually taught most of the others how to fly. They put their money together and bought a Piper Cub or something like that, sort of a small light aircraft, and Bjarne taught the others, including Mark, how to fly. So he did know how to fly, but I don't think he'd ever really flown jets except for getting rides from some of the others on the T-38s that the astronauts have.
That's great. Thanks, Chris. So speaking of books, for a future episode of Cafe before Christmas, everybody should bring their favorite book, and we can maybe talk about that as well. Okay, so Wyman, I'm going to spin over to your question. You asked about the Observer's Handbook. something that we've all recently received, hopefully in the mail. We kind of beat the postal change, and hopefully everybody has their handbook. So the handbook, just for my comment first, handbook is kind of a compilation of a lot of articles, and some of them don't really change because there's like descriptions of eclipses, and I think there's a whole section on the moon. There's tables in there which are more kind of time sensitive, so there'll be like positions of the planets over the months and things like that. So I think it truly is a handbook. Like it's kind of like a reference book. I don't think it's anything you'll necessarily read from cover to cover, but you'll refer to it as as a handbook, and when you need to look something up on a specific event. I'll open up the floor. Does anybody else want to comment on how they use the handbook? It's been around for a long time.
Can I just say too, because I did a series long ago about what's in the handbook, and maybe I should do that again.
Yeah, it's almost time for you to do that, Chris.
Yeah. So just to point out that one of the probably the most useful sections for us is the calendar that starts. It's called the Sky Month by Month, and that's a very useful section. It starts at page 94.
Mm-hmm.
And that's one that often gets looked at, and that has where Jupiter's moons are, what is the phase of the moon every couple of days, and then key events during the course of the month. Can be very useful. So that's one thing to look at and get familiar with right off. And you won't be able to see it because I'm sitting in the back here, but if you look at that part of the handbook, it's got a little triangle on the bottom right-hand side with the idea that maybe you cut it off as the month ends. And so that way you can thumb right to those pages. I guess that's the idea. So one section that's, if nothing else, have a look at that.
That's the part I use.
Yeah.
It's also a good kind of glossary of astronomical terms. I think when you're starting, you may not know terminology like perigee or apogee and all these different terms that we kind of throw around. So it's useful for that. It'll talk about kind of like the units or scales that we use in astronomy. Yeah, it's a good reference book, I think. A good companion to that is the almanac. And I don't know if everybody has purchased their almanac for this year, but I think Lori, who did that? Was it Nicole?
Yes, Nicole Martellaro.
Yeah, she
Who
did
does
she did an amazing job for 2025. I really like the format. It's really well done. Very well done. So if you haven't got a copy, well, it's too late to order now, I guess. But I think
I still have copy for those of you who have ordered them. I have them, and I'm getting to the point of being able to go down and have a what I call my calendar run, and I'll just kind of drop off things to people. So we'll have to get that going. But I do have them. Ready to go. I think I've got about 10 copies, something like that.
So if Lori runs out, I'm pretty sure that Bolen's might have a few copies as well. They normally carry it.
And the Friends of the DAO gallery, our gift shop, has also got 2 or 3 copies.
You're going to be open on Saturdays, right? Leading up to Christmas.
Yes, we're open Saturdays, starting this coming Saturday for 4 straight Saturdays in a row from 11 till 3. So if you want to come up and that might be an idea. I could be sitting at the RASC table and people can come up and pay me for things. Okay, anyway, we'll work on that. So yeah.
Okay.
All
right. So I hope that at least partially answers your question, Wyman. And I think Chris will likely do a repeat of what he did several years ago. So that's great.
There are a couple of other things too, David.
Go ahead.
If in the pandemic, Jenna Hines and James Edgar did a whole series of they took it chapter by chapter and they did it all online, and I'm not sure whether they're up as YouTube videos, but they could be. I'd have to go back and check that. But that was where I certainly found really interesting, because I was able to go in and they would just go through the each of the sections bit by bit. I mean, and I think that's what you did, Chris, as well. And it was really very helpful. And there's another fellow called Victor Abraham, and he is from the Hamilton Center, and he has got a 40 questions on a scavenger hunt of the of the handbook. And I thought that might be kind of something to kind of be fun to do, is to go through it with that kind of thing. He said he'd be happy to give those questions if we wanted to have some time. You have to be kind of there, a little bit, maybe in person. I don't know whether you could do it over, maybe you could do it over Zoom as well, and everybody could just have their handbook out and you're frantically looking up, something that you could find. And it actually makes you go through the handbook a little bit and learn some of the parts. So, yeah.
That's a great idea, Laurie.
Yeah.
So let's put that on the
try
calendar.
That. Yeah. Let's try that and see. Yeah.
And Laurie, it does look like at least one of them is still there. The RASC ones on YouTube.
Okay, well, let's do a hunt for them, and if we do find any of them, let's let Joe know, and he can augment the transcript for this edition of Cafe.
David,
that sounds.
Laurie, you could, if we did Laurie's idea of that
scavenger hunt.
Scavenger hunt, that's the word. We could do it in little teams and make it competitive, and then it's more interactive. If you know what I mean, than 25.
Yeah. Oh, yeah.
Yeah.
Yeah, that might be fun. Nobody would want me on their team.
Versus Machosen versus Oak Bay versus the Peninsula, Yeah.
All right. Okay. Is there anything else for this evening? Dave, do you have any photos to show us, or
Natasha wanted to
say
something.
I'm going to get to Natasha.
Okay. Oh, sorry.
Yeah.
And Randy's got something here.
Well, we've got to talk about next week, but we'll do that at the end.
Yeah, we'll do that at the end. Yeah, I've got you in there for next week. Go ahead, Dave.
I can't really show anything because of my internet connection is not that great.
Okay, that's fine.
It'll just freeze up as soon as I try and show.
You want to put a plug in for the astrophotography SIG?
Yes, we're meeting a week on Wednesday. So we meet on the 4th Wednesday. If anyone's interested in astrophotography, taking pictures of solar system or deep sky, please, you can easily join through the website or just send along an email to myself, and we'll get you started. We have a lot of fun showing pictures and talking about them once a month.
Great, thanks, Dave. Carlos, you have your hand up, or CJ, I should say.
I just wanted to get back to Laurie's idea that she had 2 weeks ago about getting online resource for the long cloudy nights that we're going to have this winter. So I don't know if you're going to let me sometimes to suggest a couple of, at least one website that I have ready here. We have 1 minute?
Yeah, sure.
Okay, so let me, so I'm going to share it. So a website that a YouTube channel that I like is Smarter Every Day. Maybe some of you know it. The host is Destin, and is a rocket engineer, and he does all kind of a science vulgarization video and quite a few on astronomy related stuff, but on the technician side of it. The last one that he's done, he does a duplex with some astronauts in the space station, and they talk about the struggle of taking pictures of stars in the space station. So it's quite interesting to see that they have the same struggle than us on Earth, but at a different level, and some specifically for the space station. Or another one is his father is actually in the team that put together the James Webb Telescope, and he does an extensive video, like 53 minutes, on why the heat shield of the James Webb Telescope has a hole in it. They punched a hole in it to begin with. And he also has another channel, which is Smarter Every Day too, where he goes even further in depth into subject. And notably, it did a series of video on the Parker Solar Probe, and he goes in detail on the nut and bolt side of a satellite. So it's fascinating. You can watch those, and it's like this one, the first one, it tells you why they chose selenium heat shields and radiation, how they measure the solar wind, and it's more on the technical side of the satellite instead of the physics and the result. So yeah, so that's it.
Well, great. Thanks. Chris, you have your hand up?
Yes, somebody was asking me if I had anything to say about space, and I said no, and now I'm going to say yes, but very briefly.
Okay.
I know some people are following the Starship, and the next flight of the Starship is supposed to take place tomorrow. And I think there have been 5 Starship flights so far, and they usually take place at the crack of dawn our time. But tomorrow the launch window opens at 2 in the afternoon. And so if it goes off at that time or in that launch window, it might mean we get some better pictures during the flight. And so anyway, I'm just mentioning that to Starship fans. I usually just go onto YouTube and find somebody who's showing it. I'm sure the SpaceX site has it, but that's tomorrow's, or supposed to be tomorrow's big event.
Okay, well, we'll have to check that out. Susan, you have your hand up.
Okay. I just got back an hour ago from New Zealand.
Oh,
and I unfortunately I was not able to see the sky. But either tonight or another time, I'd like to talk about the observatory experience, or near the observatory at Tekapo.
Oh, we'd love to hear that.
Yeah, so I have some strong recommendations for the Friends of the Friends of the Universe, Center of the Universe.
The FDAO, yeah.
The FDAO.
Yeah, that one. Yeah, because I mean, the brief version is I paid $129 and did not get as much value from that as a typical night at up the hill. And so I wanted to, wherever the appropriate people are to talk to, I wanted to talk about that experience and what you might want to think about. So
excellent. I look forward to that.
Yeah.
Yeah, thanks,
so
Susan.
I guess not next week, but maybe the week after then.
Yeah, we've got a couple of weeks gap. I'll explain that in a second.
Oh,
but yeah, thanks for your comments. We probably should go to Natasha, and then we'll go to Randy. So Natasha?
Yes, thank you. I'll just share my screen quickly, and I just put into the chat the particulars about what I'm talking about. So it's tomorrow. It's rather late notice, so it's tomorrow at 5 o'clock our time. And it's hosted by the Astronomical Society of the Pacific and NASA's Night Sky Network. So Kimberly, who is a very engaging presenter, she's been with Chandra for many, many years. So she's going to give a tour through some of the most energetic sites to see, 3D prints, sonifications to hear of Chandra's discovery, starting from stellar nurseries and moving to exploded stars, black holes, galaxies, and clusters of galaxies. Experience how we translate information of Chandra's exciting universe into images, time-lapse movies, virtual reality applications, and even sound. So she's a dynamo and really is an effective speaker. So yeah, if anyone has time, Jim Hesser pointed it out to me, and I just wanted to share it with everyone because it's free.
Great. Thank you very much. Okay, so we're gonna probably end the night. I have oh, okay, so we were actually not gonna meet here on Cafe until December now. So there's a reason for that, and I'd like Randy to explain what's happening next week.
Great. So it's our annual buy and sell party here in person at Fairfield Community Center. So all you people who are out in Zoom land, come on down. Last year it was super, super successful. First time since COVID. But we fill up this room with people who bring their sometimes junk and sometimes really good stuff. And we'll do some just general schmoozing. That's always fun. And we'll also kind of shut everybody up, and then kind of anybody who wants to talk about the gear that they're trying to sell or books or whatever, we'll get a chance. So what is very clever is if you have something which is either too heavy or is kind of a specialized nature, so it's kind of expensive, then it's a good idea to contact Joe, and he will put it onto the website. And we can put it around to the email. So if you have some fancy equipment that you think somebody is just waiting to buy, but they don't know it yet, then that's really good. I would say that things under $100, if it's a good thing, they go. There was a lot of stuff. I went home with a full car, much to Eva's dismay last year. But some of it was absolutely, I've been using it a lot ever since. So bring your books.
So Randy, should people bring cash?
I think people should bring cash, although it's also really easy now to do e-transfers from your telephone.
Good point.
And so if you have a way to accept an e-transfer with your bank app, then you don't have to deal with it. But otherwise, cash is the easiest way to do these things. I also should say that a lot of people just say, take it, okay? They bring things that they just don't want to have in their inventory anymore. And this is a great way. There's lots of people who are really keen. Can I just put up my hand and say, I would love a reducer, a 1 1/4 inch reducer, because given my 3-inch Mac and my crop screen camera, I cannot get the moon I can't photograph the whole moon with my camera. So I am in the market for a reducer. If anybody has that, and under my $150 rule, but that should not be difficult for a reducer, then I'm in. So yeah, I guess that's another thing. If there's things people are saying, I sure wish I had, there's a lot of gear in this club. And a lot of people have things that they just never use. And so this is a good time to do that. It's also a great time to see each other in person. I think we had 30 people in this room last time.
Will you have cookies?
There will be cookies. There will be coffee. I just want to also say to everybody, we're so thankful to have Kathy, who took the initiative and brought coffee back to the Astro Cafe. So it's a regular.
Okay, thanks.
So do come next week, please, please, please.
Okay. Well, that's great. I just one last plug. Beginners group, first Tuesday of every month. So just let me know if you want to join, if you're not already part of the group. And I think Kirsten is going to talk about eyepieces and gear and stuff like that. Probably just in time for Christmas. So please let me know if you want to sort of join us. And yeah, this is great. I hope we'll see everybody at the buy and sell next week. Anyways, good night.
Good night.
Thank you. Good night.